Hello, everyone, and welcome to week 6 of an introduction to agent-based modeling. And the first thing I want to talk about, right, is that during this week, you will be seeing the end of Unit 4, essentially, right, which is, as I mentioned, one of my favorite units in the entire course. And it all went up last Friday, I believe, sometime towards the end of last week. And the one thing I want to mention, just to make it very clear to everyone, I'll send this out in the email and I'll send out today as well, is that if you went ahead and watched the other aspects of Unit 4 that were in like the end sections, like the Tom Schelling interview, or you went ahead and looked at the assignment, for instance, you're going to have to go back and click back, right? Because normally when you load Complexity Explorer, it automatically shows you the next unit that's available. Well, because I added some of these after those units became available, right, then they're actually behind it in a way, right? So you'll have to go back, and you can do it. You can just click back and say, I want to go back and look at the rest of Unit 4, right? And specifically make sure you've watched Units 4.4 and 4.5, as well as done the Unit 4.6 test and everything like that, right? Okay, so that's the most important note. I want to make sure everyone's aware. I did kind of break the system a little bit when I posted some of the units ahead of time. I knew that was going to happen. There just wasn't a much easier way to get the assignment to you as early as possible, right? So I wanted to make sure that you had that assignment so that you could start working on it. So that's the biggest announcement this week. Next week, we'll be working on Unit 5, and I should have that up. Actually, it may be up like early this week, so keep an eye out. It may be up in the next couple of days rather than waiting toward the end of the week, because there isn't much to update in it, but there is a couple of things I am currently in the process of fixing, but I hope to have most of them done today. So Unit 5 should be up shortly. Unit 5 is nice because it goes back and it takes apart, now that we've built up an agent-based model from the ground up, Unit 5 talks about what all the components of an agent-based model are. So I think you'll find it very interesting as to what to look at. Other things. So there were a couple questions that came in on the various forms of communication. One of them was about R, right? So at the end of Unit 4, we do use the R software package a little. And R is a freeware statistical modeling package that works on any place NetLogo works. So you should be able to get up and running pretty quickly. I highly recommend, if you're interested at all in working with like data analysis, doing statistical testing on data, examining data in any sense, looking at the outputs of models and simulations even, right? I highly, highly recommend playing around with R. It's a great way to kind of do the kind of analysis that you want to do in a lot of those cases, right? So let me bring up, I'm just going to bring up the R project website so you all can see it and make sure that we're all on the right page. Let me get rid of some of these old windows, and then should be able to bring it up pretty quickly. Okay, window capture R. There it is. Okay. So there you go. There's the R project, right? And so, it's at, and if you look at it, let me see if I can zoom that in a little bit for you. No, that's not what I want to do. So it's at rproject.org, right? So that's where you go to get it. It's a pretty straightforward install. If you have a Mac-based computer, the standard R interface is pretty darn good, and you don't really need any additional content. If you don't have, if you have one of the other machines out there, you might want to see there are a number of different add-ons to R, most appropriately R Studio, which I really like, right? Which also provides you with a nice kind of interface to play around with R, and it's also I believe freely available for non-commercial use. Because I use a Mac-based platform for most of my work, I actually don't use RStudio that much. Occasionally, I do run it in when I need it, but I have it installed on all my machines. So it's easy enough to just use the Mac-based. So there you go. There's RStudio, right? Highly recommend downloading and using that if you don't have a Mac. Okay, so R is coming up for sure. It's important to do. Oops, sorry, gotta mute that mic. Okay. Someone in the chat actually asked, I've been using, Chris Butler, I've been using Python Jupyter notebooks with various stat packages for analysis and other moves. Any reason I couldn't try to use it instead of R? No, in fact, feel free to use Python. Python Jupyter is a great way to go, and I highly recommend that as an alternative if you're familiar with that. I just find R easier to teach for people who have no experience with these kinds of statistical software packages in the past. But if you have a package you're familiar with already, I mean, Python Jupyter is a good way to do it. SAS, even, you can do your analysis, MATLAB, Mathematica, right? Any of these ones. I just find R to be kind of the easiest one to teach right off of that, so I usually suggest R. But if you have another package, software package, you could even use Excel. There's some description in the textbook about how to use Excel, but I find R to be slightly more powerful and easier to use. I often use, by the way, Chris, I often use Python myself. However, when it comes to doing visualization of data, I find R to be a little bit easier for me. That's not necessarily true for everyone. And so a lot of times when I'm looking at model results, I'll use R. But when I'm pre-processing data, getting data ready to go into my model, I'll use Python. It's all kind of, 6 one, half dozen the other. Depends upon what you're most familiar with. Okay. There's also been continuing a couple of questions where people have said, hey, do you know about a model that does X or a model that does Y, and this is the kind of model I want to build for the class. And, a lot of times I do, and I will share some ideas when I know about them. But, many times, it's maybe a little bit outside of my area, and so I don't know of any models in that area, right? I just want to point out again, it's always good to kind of look at the NetLogo community models. Well, NetLogo models library to begin with, NetLogo community models, NetLogo modeling commons, the OpenABM project, and then if all else fails, right, like going to Google Scholar and actually Googling for agent-based models and whatever the subject is always a good way to go, right? I will also retweet things on the Intro to ABM Twitter channel occasionally that I find about new agent-based models that have come out. So that's another place to look. Also, just posting to the community, the discussion forum, right? Like if you don't know about where to find a model that looks at, a certain sub-niche that you're interested in, just throw a question up on the discussion forum. A lot of times people know about a model like that that they played around with or they've seen. So that's always a good place to look as well. I had some questions about how people wanted agents to have different. No, that's not the one I want to talk about. So here, this is a question that came up in the discussion forum. So so somebody had a question about, like, if I have 10 turtles and I want an exact structure where turtle 1 connects to turtle 2 and turtle 2 connects to turtle 3 and so on down the line, right? How do I do that, right? Well, you definitely can do that in NetLogo, don't get me wrong. But a lot of times it's not a great idea to actually directly connect them up in a specific structure. It's a more agent-based modeling way to allow them to connect up to a random other turtle that has a certain property, right? And the reason why I say that, right, is that a lot of times when you think about building models, you want models that are robust, even if you change the number of turtles, change the size of the world, change a bunch of the properties. And if you have the turtle set up so that turtle 0 always connects to turtle 1 and turtle 1 always connects to turtle 2, right, then that makes the model a little bit more brittle, right? So it's not that there's anything, it's not illegal. It's not going to break any of the rules of agent-based modeling to do it that way. But a lot of times that's not the way you actually want to do it, right? You want to figure out some sort of general set of rules. That being said, there are some cases where you do need to build it that way. In fact, there's one in the NetLogo models library that does that. So I want to kind of show that to you real quick. So let me bring up my window for my NetLogo models library. No logo, no logo, no logo. There it is. Okay. Okay. So let's make this a little bigger. Okay, so you're not going to see the models library selection, but the models library you're going to want, the model you're going to want to bring is called, that I'm going to be looking at, is under, it's under networks, and it's called small worlds. Right? And this is a classic model that looks at the small world phenomenon, right? And the small world phenomenon is this idea that everyone is fairly closely connected to everyone else in the world, sometimes also called the Kevin Bacon phenomenon, right? Because apparently Kevin Bacon works with every actor out there, right? Let me actually, it looks like I've got this a little, no, it's okay, I'm good, okay. So in this model, let me make the font size a little bigger. When you go down to the setup procedure, and this is something that you can take advantage of, there's this procedure called wire them, right? And that's the one I actually want to show you. Right? So let's look at what this looks like real quick. So when you hit setup, right, you get these turtles, and it turns out that these turtles are set up in such a way that each one is connected to the two neighbors on either side. So as I click this highlight button, it lets me see that, right? So the pink turtle is the kind of focal turtle, and the blue ones are its neighbors. So they're connected to the two on either side. So how does it do that? Well, if you look at the wire them scenario, right, it basically iterates over the turtles by saying let n equal 0, while n is less than the count of the turtles, make an edge, which is another procedure, I can show you in a second, between turtle n, so that's turtle 0 at first, and then turtle n plus 1 mod count of turtles, right? So initially, if n is 0, then it's going to be 1, and then the second one makes it edge to turtle 2, right? So that's turtle 2, right? Now you might say, well, wait a second, it was connected to 4 turtles, right? Not just 2 turtles. Well, that's because when you think about it, when it comes to the turtles on the other side of it, they're then going to make an edge to that turtle. So because these are undirected edges, the edges to and from are going to add up to 4 total. And then it just increments that counter. Now, what does this mod count turtles do? Well, once you get, let's say there's, in this case, there are 40 turtles. So let's say we get to turtle 38. That's fine, because 38 is going to make an edge to 40, right? Actually, let me take that back a second. We start with turtle 0. So when we get to turtle 37, it's going to make an edge to turtle 39, which is the 40th turtle. But when we get to 38, then this code right here is going to try and make an edge to turtle 40, and there's no turtle 40, right? Because we have 0 to 39 turtles, right? So mod count turtles, right, is going to take that 40 and make it a 0. So this is now going to be a 0 instead. Mod basically says take a number, divide it by this other number, and give me the remainder. So 40 divided by 40 is 1 with a remainder of 0. 39 divided by 40 is 0 with a remainder of 39, right? So it gets 39 back, right? And so then when it gets to turtle, 39, this code is going to make an edge to turtle 0 because 39 plus 1 is 40, remainder 0. And 39 plus 2 is 41 with remainder 1, so this code is going to make an edge to turtle 1, right? So you can kind of come up with ways to automatically create these structures, but as I said, you know, it's not the best way to do things in agent-based models because often we want it to be less. We don't want it to be brittle. Now, in this case, in the small world code, right? Actually, if you look at it real quick, they did make it a little bit more. It's not very brittle, right? Because even if there's 100 turtles, all this code still works, right? It's not restricted to the number of turtles there are. So that's at least some hope. And I'll show you and there will actually be an example in Unit 5 where I actually do this myself just to kind of make things a little easier. But a lot of times you'd rather have it, say, for instance, make an edge between a turtle that has less than 4 edges and another turtle that has less than 4 edges, right? Something like that would be a way to do it. But then you don't get these nice properties that looks like a sphere and everything like that, or circle. So I understand why they did it the way they did it. But just an example, okay? So let's see. Another question came in about what do I mean by global knowledge, right? So this question was along the lines of, right, that we said a lot of agent-based modelers, a lot of agent-based models shouldn't have global knowledge, that the agent shouldn't have global knowledge. What we really mean by that is that the agents shouldn't have access to knowledge that they wouldn't have under the conditions that they normally be making decisions, right? So for instance, one way to think about this, right, is that if I'm a farmer, for instance, trying to make decisions about what to do with my farm, there's certain types of global knowledge I might have access to, right? So maybe, for instance, the price of grain last year was published in the newspaper or an almanac or something like that, right? Then I might have access to that information, right? So I could base a decision based upon that. But there's also the case that if I was actually a truly optimal farmer, I might be trying to figure out like whether or not Bob down the road is going to plant his grain this year or not, because if he plants his grain, that makes my less grain valuable. But maybe there's no way for me to know that, right? Or maybe I can only guess probabilistically whether or not he's going to do that, right? That's the kind of global knowledge that we don't think that the agent should have access to. Right? And in our case, even things like prices are locally determined. They're not globally determined, right? So for instance, the price of grain to me on the global market doesn't matter much. What matters to me is what the wholesaler or distributor that I normally sell to, what they're willing to pay for my grain, right? And so that's a better model of local knowledge interactions than the model where I instantaneously have access to all all the market prices everywhere in the world, right? So that's what we meant when we said that agent-based models often try and model scenarios where you don't have access to global knowledge. So those are most of the questions that came in. Just going to check one thing real quick. There was some questions again about like subsetting a bunch of things, right? Like changing shapes for specific turtles, right? Yeah. So this is kind of related to a question we talked about last week, right? So if you remember last week, let me bring up that model. We had an example of where is it? So we had an example. Let me bring up the network window again, where someone wanted to plot different turtles in different colors, right? And I said, well, a great way to do that is to use the Wif command, right? Which the Wif allows you to select. And if you look in the code for the plot window that we did, right, we did this. Oh, yeah, I think it always doesn't show that. Give me 1 second. Okay, there it is. So if you remember, I said that there's this Wif command, right, that allows us to kind of say just plot the turtles with color equals red, right? Now you could do the same thing. So someone asked specifically, how can I change the shape for specific turtles if I have 2 different types of consumers and retailers? I want each type to have a different shape and different rules, right? So in this case, right, we have the different red and blue turtles, but they don't do anything. Now let's imagine that the red turtles are consumers and the blue turtles are retailers, right? Well, then we could set their shape to be different. So we could set the shape for the consumers to be person and set the shape for the blue turtles to be house. Right? Let's see if I think those both exist. And now, oh, I got to turn off. I overlaid it. Hold on 1 second. Let me show you that again. Okay. So what I did was I just changed this code in here, right, to set the color red and set the shape to person, set the color blue, and set the shape to house, right? So here I did it in the setup. I could have also done it in this way, right? Ask turtles with color equals red. Set shape person, right? And that would have also done it. So let's do it that way, just because that's a more useful way, because you can do it outside of it, right? And then I could do the same thing with blue to house, right? And now You see this when I hit setup right now, all the red turtles are people. It might not be super obvious because it's a little hard to see. Oh. I think I'm moving my stuff all over here. Hold on, give me a second. Okay. No, I want this one. Yeah, okay. Right, so there you can see it, right? So we've got the red people and the blue houses, okay? So, and I could even have them act differently, right? So right now, I have Ash Turtle is forward 1, right random 90, left turn random 180, right? But let's say I want to only do that if, let's say we only want the people to move and not the houses, right? So then we could say, ask the turtles with a shape equal to person to move, right? And now you can see, and in fact, you can see that the houses don't move, and the blue line now just stays constant, right? So clearly, this is one way you can have people, the agents, move differently from each other. Now, if I really, really wanted to do this, and this is actually covered at the end of Unit 4, in section Unit 4.5, I really wanted this to go the whole way. I actually should set up what are called breeds. And breeds are kind of subsets of turtles that have their own specific characteristics. And so what I could do is I could go up to the very top, and I could say breed, consumers, consumer. You have to give it a plural and a singular. Shops and shop, right? And so now I can actually, rather than creating 100 just turtles, I can say create consumers 50, create shops 50, right? And what this lets me do is I can get rid of all this randomness, I can set the color, right? Oh, I probably want to copy over that set XY to the other one setup, right? And actually, we can leave the rest of this code alone if we want. Check it real quick. It looks like it's fine. Because even though they're consumers and shops, they're also still turtles, right? And so as a result, all this code that talks about turtles with color equals red and turtles with color equals blue will still apply. So if you see setup and hit go, it still works exactly the same, even now that I've called it breeds. But there are easier ways to do this. So now I can just simply say, ask consumers, set shape person, ask shops, set shape house, and then I can, in the go command, just say ask consumers move, right? And so now, right, I've got these consumers and these shops that are moving independently of each other. In fact, I can even make it easier than this because there's a special command for breeds for shapes where I can say set default shape consumers to be person. Now, you want to do this before you create any. So I want to put it up here at the top because it's going to set it for when they're actually created. And I can set default shape shops. Right? And this basically means anytime you create one of these breeds, much like the turtle has a default shape of the little triangle thing, right? We could say that the breed should have this default shape. So I can set up and I can go, right? And it creates it exactly the same. And let me just show you that it actually does work. So I can change it. I can set the default shape to circle, and now when I had set up, now I get a bunch of circles instead of houses. Okay. So breeds are really powerful. They're kind of like a weak form of object-oriented programming, and NetLogo will talk some more about other kinds of relations to that. But you know, that's one example of how to do what the questioner was asking. Okay. So I'm going to save this one off just because I'll upload it as an example of breeds for the and it'll be in the office hours. Okay. Oh, I didn't mean to do that. Oh well. I accidentally closed out NetLogo, which I didn't mean to do. Okay, let me bring my own camera back up. Okay. So let You should be able to, sorry, DA, it says you can't see anything. You should be able to see things again now, hopefully. If you still can't see anything, just let me know. But I think I got everything up and running. If there's something that I covered over, let me know, and I'll go back and show it off again. And so there were a couple of last other questions that came in. Let's see. Oh, somebody asked about the NetLogo BAS model from my paper with Roland Ross. You know what? The truth of the matter is I used to have a website devoted to that paper, and my website died because I moved schools at some point. And so I need to get that built up again. But in the interim, I will make the code available. I'll probably just upload it as an answer to the question on the discussion forum so everyone can get access to it, okay? So I will put that up there, and you'll be able to get access to it shortly, okay? This is the diffusion model that we built for the BAS model, okay? Let's see, other questions. There was a question about examples of machine learning and agent-based modeling. That we'll get into a lot more as this course goes on. There will be several examples in units 7, 8, and 9, 8 and 9, I think, that will discuss machine learning and agent-based modeling. You've already actually seen a couple. If you go back to unit 1, there are a couple of quick examples which I touched at a very high level. The L for all bar problem actually is an example of machine learning. It's a very weak form of machine learning, but it's basically this bag of strategies form where you pull a strategy out that works the best. Yeah, and so and at the high level, I think I've talked about this a little bit before, but I see two major uses of it, and not just these aren't the only uses, but two major uses of machine learning and agent-based modeling. One is to calibrate a model, to take a real-world data set and take the output of a model and then adjust the parameters of that model to make the output of the model fit the data set better, right? And you can use machine learning to do that. And then, so that's kind of in the calibration space. And another is what I call the rule induction space. So this is cases where you don't know what the rules of the agents are, but you have a bunch of data about individuals moving around or making decisions. And you can infer rules directly from those agents and then see if once you take those rules out and you embed them in the model, they create a more emergent process that matches macro patterns in the real world. So those are two quick examples and are two quick kind of paragons of ways to use agent-based modeling, machine learning and agent-based modeling. But yeah, if you could hold off a little bit on that, I'll kind of give you some classic examples in units 8 and 9, basically. This is an interesting question that Santiago Renteria asked about why are some aggregate models replicable with agent-based modeling and some aren't, right? Well, he didn't say and some aren't, but that was kind of the implication. It's one of these things where in a kind of silly sense of the term, right, all of them are, right? Because agent-based modeling is a Turing-complete language. All of these equation-based models are also Turing-complete languages. You can always write one that replicates the other. Now, whether or not you do that in a way that's kind of true to the spirit of agent-based modeling, that's an interesting question. I think the more interesting question that Santiago was asking, I think this is what he really intended reading from his question, right, was what properties of an aggregate model lend it to easily be replicated by an agent-based model? And I think that's a very interesting question. It actually strikes me that I don't know if I've ever actually sat down and wrote out the rules. But I do remember that when I first started working in business and management, I saw the BAS model, and I said, this is an agent-based model, right? Like, that's just what it sounds like when you read about it, right? And it was only after I actually dug into it a little bit, and I realized that it wasn't implemented in any way as an agent-based model. It was implemented this weird, well, not weird, it's kind of very normal hazard rate model, but a model that was kind of a little foreign to my understanding of the way I would have implemented it, right? In the end, it's not really even a predictive model the way it was originally written, right? It was written as this descriptive model of data that already exists, right? And that was kind of intriguing to me. So what about the BAS model? This is a good question. What about the BAS model made it interesting from an agent-based model perspective, right? Well, I think it's because partially when you read over the description of the model, it's written like the conceptual model. it's written that there's these two influences on people: this natural innate ability to innovate and to adopt new technologies, and then there is this like social pressure to look around you and see what other people are doing and adopt what they're doing, right? And those two factors are what cause you or kind of encourage you to adopt a new technology, right? And with the way that conceptual model was written, it was written from the perspective of an individual consumer, right? And that is what made it easy to replicate using an agent-based model, right? It also turns out that once you get into some of the technical details, right, hazard rate models can essentially be written as individual level models once you express the probabilities correctly and everything like that, right? And I also want to caution, right? Like the original in the Rand and Rust paper, we weren't directly trying to build a one-to-one match to the underlying BAS model. What we were trying to do was take the conceptual model and re-implement it as an agent-based model, right? And then we showed that re-implementation got similar or at least as good results as the aggregate model. And the reason why I want to mention that is there are a couple of small different ways that the probabilities are handled that mean that the results aren't comparable at like the 10th decimal place, right? And so the goal of that model was not a perfect replication. It was a replication to the level of achieving similar results, right? And so I do want to mention that. And I think that's true with a lot of times when you implement agent-based models at aggregate level models, right? A lot of times you're not trying to achieve a literally, precisely the same numerical replication. You're trying to achieve a qualitative level of replication, right? Maybe even quantitative within some sort of error bounds, right? Anyways, that's a small aside, but and I think that a lot of aggregate level models probably could be implemented. I think the kinds of models that maybe don't lend themselves well to being replicated in an agent-based model are aggregate level models that seem to take a lot of global information into account, right? That seem to have all the agents knowing exactly how all the other agents are acting at the same time, right? To some extent you could build those models, and sometimes you could build those models. I wouldn't call them agent-based models, but you could build those models at the individual level, right? And then you can slowly decrease the amount of information that's present and see how the model deviates from the aggregate level model, right? I think another type of model that's hard to replicate is models that have more entities at the how can I put this at the higher level, right? That they have a lot of populations as being key constituents of the model, rather than having agents be key constituents of the model, right? A lot of times, again, you could replicate that in an agent-based model. Sometimes you'd wonder why you want to, right? But there are a number of different ways in which you could do that. Like I said, just to get back to the overview, everything could be done as an agent-based model. The real interesting question is what models would nicely lend themselves or would be useful to implement as an agent-based model. I don't think the real question is which one can you or can't you implement as an agent-based model. Okay? So I think that's all the questions I have for this week, right? If you have any other questions as you're going through Chapter 4 or the assignment, please email me, right? Just to summarize again, we're wrapping up Unit 4 this week. The assignment is due, and let me double check the exact date, right? So the assignment, I'm pulling it up right now. I believe it's due. So the model design assignment must be uploaded before July 17th at, for some reason it's now 12:59 a.m. Pacific Daylight Time. I thought that was 11. It might be a daylight thing. But anyways, 12:59. You get an extra hour on it. 12:59 a.m. Pacific Daylight Time on July 17th, right? So 1 week from today, okay? So definitely get that in. And then once that is in, right, then you'll have 2 weeks to complete your peer reviews for that. Right? So that's the most important thing to be working on this week, is to do the model design assignment. Also finish up Unit 4, and Unit 5 should go live soon. That's it for today, and hope you all have a great week. Take care. Bye.